All right, well, everyone, we'll just get started because thank you all for many of you for joining me on your lunch break. And for others, if it's a different time zone, thank you for joining me in your evening. So today we are going to build a computer vision model with no code. So maybe you saw the video that I had created a while ago, basically demoing essentially a way to build a simple computer vision model. In my case, I built a computer vision model as to detect whether my cat was on the couch. And you might be asking, well, okay, is that really a big deal? Like I have eyes, I can see if my cat is on the couch, right? So yeah, this is a very simple way to basically test out Groundlight's platform. And maybe in this case, you might be testing it to detect, whether you're wearing glasses, whether the cat is on the couch. But there's a lot of really powerful things that you can do with computer vision and Groundlight's platform other than detecting a couch. So I'll give a little intro before we get started. So today, yeah, just going to do an overview of our platform, going to tell you basically how to test it out without any code. Without using Groundlight's Python SDK. But for advanced users, I'll point you to some resources on how you can build your own custom computer vision application using Groundlight's Python SDK. So that is to say, today is essentially a way to test out, learn about computer vision, but without necessarily needing to write any code. So Groundlight can keep watch for you. And we have some examples here, like, is there more than one customer at checkout? Is the person wearing a company uniform? But essentially, there's a lot of different things that you can do with computer vision. We have something called the Groundlight Hub, which is a device that you can install to essentially just run computer vision on premise. And Groundlight's AI and 24/7 human staff build custom AI models from you. Oh, hey, Lou, nice to see you as well. And also, Groundlight provides custom analytics and real-time alerting. So in the case, for example, is the person entering wearing a company uniform. If our model detects no, then you would get an instant alert, whether it's through a text message or an email or whatever way you want to be alerted. So here's an example of one thing you can do with Groundlight AI, and this is essentially asking, is a person touching an item? So you can see this is a pretty sophisticated, it's detecting, people, they're walking around. Okay, so now the person's touching an item and you can see that it becomes red. So this is a really, really cool and advanced way to do retail analytics. E-commerce sites have the ability to collect a lot of data. However, for brick and mortar stores, you don't necessarily have the ability to measure, for example, abandoned cart. So this is just a way you can use computer vision to collect retail analytics. And then here's another way that we use vision-guided robotics. So here, this is a recent show we did. So this is our integration with Universal Robots, the industrial robot arm. And essentially what this is doing is, as the robot arm is moving along, Groundlight is performing visual inspections and like safety checks, for example. So here it'll detect if there's a tool in the way, it'll detect if there's a part missing. And so this allows you to basically run a lights out operation. Like normally you need people to be checking manually, making sure, like in this case, that the part is placed correctly. Sometimes the robot arm drops a part, the part is misaligned, that can stop your production. And as you know, lost time is lost money. So that's a way that Groundlight is integrated with robotics in the manufacturing space. Next, okay. So yeah, basically what we say at Groundlight is that we provide the reliability of humans with the speed and cost of AI. And just kind of quickly going over, like many of you are already familiar with computer vision, but as you know, like traditional computer vision, you have to first collect your training data. You have to label it. You have to organize it. You have to process it. And then maybe by day 90 or 100, you can finally deploy. With the Groundlight, you can deploy instantly. And you can basically have a working application instantly. And why is that the case? Because we have humans in the loop. So as your model is running along, you basically are able to, anytime the environment changes, the ML will actually notify you, hey, I'm actually uncertain. I've never seen this before. The scene has changed. It'll actually escalate to a real human who will confirm and guide the ML to the correct answer. So that is to say, traditional computer vision, it's very clunky. It takes a long time to deploy. Groundlight lets you do that right away. And yeah, this is to say, like, this is a simple demo, but you can build your own custom applications using Groundlight's Python SDK. And we have a tutorial for Python SDK. We will probably do some webinars as well to run through that, but I won't get into the code as well. But I'll drop some links later on if you are interested in building your own custom application. That said, you're also welcome to schedule a call with us, and we'd be happy to discuss with you how to build your custom application. Either Groundlight can do it for you, or we can help guide you in how you can build your custom application. So,
hello.
Yeah, so today, first, I dropped the link. Just visit groundlight.ai, go to try it free. It is free. And the first step is to register for a free account. And then we're going to go to the Explore tab of the dashboard. And then it's going to ask you to connect your laptop camera, because today we're going to be using our laptop camera to train our model. And then you're going to create a binary query, or what we call a detector. And a detector is essentially a computer vision model. And you can ask something like, is the person wearing glasses? If you have a pet at home, you're welcome to point the camera to your couch and detect, like what I did, like if the cat is on the couch. But you can basically snap, 10 to 15 images of yourself wearing glasses, not wearing glasses, and then we'll let our computer vision technology analyze the results. So that's pretty much what we're doing. And with that, I will show you. I'm going to go to my other computer now where I have my detector. And I'm going to share my screen and share. Yeah, let me share my window. Oh, no. I'm going to share my tab. Okay, so this is the detector page. Actually, before I do that, I'm going to show you where to sign up. And you're welcome to follow along as well if you're looking to just check things out. But basically, on our homepage, you simply click try it free, and then you sign up. And with that, you'll get a free account, and you'll be able to build your own computer vision model. So I'll pause for a second just to let people catch up and do that. Let me know if anyone has issues signing up or creating an account. Okay, I'll give another like 30 seconds in case people want to do that. If not, I'm just going to continue chugging along. Okay, so here we are at our detector page. So you can see I've actually created some detectors already. This is a fun one that I created using the Groundlight Hub. I wanted to detect if a package was at my doorstep, so I put a camera out in front of my door. My neighbors were a little concerned. They're like, are you watching us? I'm like, no. Seriously, the camera is facing my door. Like, don't worry. But essentially what I did is I simply just put out a bunch of packages and allowed the model to analyze whether it was a package or not. I also put a lot of different objects. For example, my daughter has a little toilet. So I put that, is that a package? And here it's like saying yes. And so that's another really interesting thing about Groundlight is you also define like what is a package. Like, is this technically a package? Like maybe if I get it delivered, it could be a package. But if I didn't like the answer, I have the ability to say yes or no. So anyway, I'll go deeper into that a little bit more. But let's start by going to the Explore tab and let's create a new detector. So basically when you first enter Explore, it's going to ask you to access your website camera. And it's going to basically also bring up this kind of window. And so you're going to need to write your own query, essentially. So in this case, I think I'll do is the person wearing glasses, You can also do, is this a person? And then, kind of hide from the camera every once in a while. Or you can also do like, is this a pen? Experiment with different objects. But I like to do this one, is the person wearing glasses? So I'll do that. And this is to note, this is a binary query. So it has to be something that can be answered with a yes or no. For paid accounts, once you get to pro level, we actually have counting as well. So you can do, for example, how many empty parking spots are in the parking lot? So you can do that, for example. And what else can you do with counting? You can do like if you're looking for an inventory management system, you can say like, how many boxes are on the shelf? So this is to say, this is a very simple query. Another thing to note here is your minimum confidence. So the default confidence is set to 0.75. What does that mean? So 0.75 basically means that if the model results in analyzes your image and has, for example, ML confidence of 0.7, that image will get escalated to what we call a cloud labeler. Or a human. A cloud labeler are basically humans who are confirming the correct answer for your image. So that is to say, the general rule of thumb is if you set it to 0.5, it's kind of like a coin toss, whereas 1 would be like every single image would be answered by a cloud labeling staff. So low settings are really great for easy questions. Generally, high settings are great for difficult questions that need help from our labeling staff. And so I'm going to keep it at 0.75. Okay, so I'm just going to say reset okay. So we're starting from 0. So you have this button here called capture image. Oh yeah, by the way, this is to say cloud labels are enabled here. And you see our confidence threshold is 0.75. So I'm going to start by capturing an image with no glasses. Okay, so now you see the image has been submitted and you see this answer of no. Right now, the model is just getting started. You see this human icon. It's being escalated to a human who's going to review whether this person is wearing glasses or not. Another thing to note, when you also set up a detector outside of Explore, you have the ability to put notes in for the cloud labeling staff. Okay, so actually now you see a pink label came in and it says no. So if you were to look, and by the way, you could also correct if you decide no, like why would you, if you decide for some reason that the labeling is wrong, you have that ability to override that. But if I look at the query details, I see that, okay, the algorithm was basically 50-50 coin toss, and it was escalated very quickly to a cloud labeler who also confirmed it was a no. So I'm gonna actually also do auto capture now. So I'm going to set to capture every, I'm not going to do that right now because I just want to capture manually, but you can do auto capture. Like if you want something hands off, like when I was filming with the couch and the cat, I did auto capture so I didn't have to manually press the button each time. So I'm going to put my glasses on and I'm going to capture an image now. Okay. So here it says no, and that's obviously an incorrect answer. So ML model needs to, ML model got some guidance like, hey, ML model, this is glasses indeed. So I'm gonna do one more. Okay, so now you see a 0.56. That is to say the model is only 0.56% sure, 56% sure that this person is wearing glasses. Okay, so I'm gonna continue capturing some images. I invite you to follow along. I'm curious what detectors you guys are creating. Is everyone else doing glasses or are you guys all doing something of a different variation? We'll do no glasses. Okay, so now it's 60% confident that there is a no, that I'm not wearing glasses. Oh, okay, great. Sydney, asking, is the person smiling? And that's an interesting one too, because even then, like, how do you define a smile? Like, I know, for example, some people have done a grimace like this. Yeah. And in that case, that's where your judgment comes in. Like you as the owner of this computer vision model, you define what is a smile, right? I'm gonna do glasses again, just to kind of keep it going. Okay, so now you see it's getting a little bit more confident over time, 66% confidence, but it's still not higher than that 0.75. So I'm going to do multiple. I'm just going to keep it going. And you don't have to wait for a query to come in. You can just kind of keep going. You can move the scene a little bit, change it. Oops. Okay. By the way, yeah, if you there's a limit of 6 queries per minute. So if you, for example, are looking to analyze images from a camera feed, in this case, you would probably want to have a certain number of queries. For security reasons, maybe you'd want to have, I don't know, like a query every 30 seconds or something activated by motion detection. So that's just something to keep in mind. Okay, capture image. And I'm doing really simple ones. And here's an interesting one where, what if I have my glasses on my head? Is that me wearing glasses? In this case, this is where you define what is wearing glasses. So I'm going to say, for example, like, okay, model said no, and I'm going to agree that this is not wearing glasses. Yes, so edge cases, exactly. Okay, so now we see 0.7% sure that the person's wearing glasses. Oh, hit my rate limit again. All right, it's giving me a countdown. Okay, wait every 5 seconds. All right, so you see, actually this happened already. So it looks like we have a computer icon. So in the past, you've seen these human icons. So now we have a computer icon here. And that's exciting because that is basically showing that the ML model has answered with over 0.75% confidence. So you see that basically the algorithm answered with 0.758, 75.8% confidence that no, I am not wearing glasses. And because of that, it has not been escalated to a real human being. Versus looking at this one, let's see, yes. Okay, yep, let's look at this one. Whoops, zooming in on myself. Okay, same thing, 75% confidence. And then versus looking at this one was escalated because it was under 75% confidence. I just want to pause for a second. Are there any questions about using this? Okay, there's a question about, what about subjective? Do I look good today? Does my outfit match? That's a good question. We haven't had a lot of those types of queries before. I will say the general rule of thumb is if a human can spot it, if a human can identify it, then it can be answered by our computer vision technology, right? So in this case, like, does my outfit match? That might be something a little bit more feasible. I think I would say generally subjective models would be difficult to implement. And no apologies for the humor. That's a good question. I mean, like, what kind of query is a good query for a computer vision model, right? So yeah, I mean, I feel free to experiment. I mean, you're always welcome to see like, hey, like, oh, hi, who are the human labelers and how are they trained for this task? So our human labelers are Groundlight staff. Some of them are located throughout the entire world. And as for their training, that's a good question. I can get back to you on that. I'm happy to email you specifically. But in terms of how they're trained, I do know that part of the training goes into the notes that you put in your detector. So when you're implementing your computer vision model, you should be writing instructions to help guide the cloud labelers. And you can even put screenshots and say, for example, this is, let's take Drew's example, like, does my outfit match today? Okay, that's a kind of a difficult one, but you could say, hey, I define matching outfit as the colors are, as the I don't know, the shapes are the same, or like, here's what a matching outfit is today. That's a bit of a tricky one, but maybe a simple one would be, if you're measuring whether a gate is open or closed, you'd have a picture of a gate that's open and a picture of a gate that's closed. And you would instruct the cloud labeler, like, please mark these as no, mark these as yes. So part of the training is also up to you, and like what notes you put. And Emily asks, are queries text only? Yes, queries are text only. So you use your natural language to ask any question that you'd like. In counting, you would ask, how many empty parking spots are available, or how many boxes are in the shelves. But for binary, of course, it would just have to be like a yes or no question. Any other questions from people? Otherwise, I can go to looking at getting projected ML accuracy, where we get a little bit into more of the details around how you assess your model and the quality of your model. I'm going to do one more image just to capture. Okay, so it's yes, 71% confidence. And so you're seeing these results, by the way, and you can kind of see like every query is populated in this graph here. Okay, so now when you're looking at your detectors, this is basically a detector that you've created. So I'm going to go to my detector, and so in case people missed that, click the back arrow button to get to this page. And so you see the query is the person wearing glasses. And you have basically a summary here of how your computer vision model is doing. So projected ML accuracy, that is to say, that is a number that we have come up with to essentially tell you how is your model doing, how is your model performing. However, here you see that it's empty. You don't have any model here at this time. What this means is that you need to have enough examples of yes and no to get a projected machine learning accuracy. That is to say, you need to provide ground truth labels. Ground truth labels are used as examples for the cloud labelers to interpret your instructions. And they basically help convey the behavior that you expect from the detector, and are really especially useful in clarifying edge cases being like unusual cases, like for example, when I had my glasses on my head, right? So that is to go back to Hassan's question on how does the training happen? So if you want a projected ML accuracy, what you need to do is you need to provide some ground truth labels. Click here, label image queries, and you see here, okay, here's that edge case that I talked about, where is this person wearing glasses? I mean, technically they're wearing glasses, like it's on my head. However, for myself, for my purposes, I am not going to define this as wearing glasses. So no. Is the person wearing glasses? I'm going to say no. Nope. Just label some images. Oh, yes, this person is wearing glasses. Okay, so that is to say you need to provide, I believe it was 2 and 2, but I'm just going to do a little bit more. Okay, so if I go back to my detector now, it looks like it's evaluating the results, and it's going to tell me essentially the performance of my detector. While it's doing that, oh, okay, great. So it has a projected machine learning accuracy of 99.99%. That is a lot higher than I expected, so that's great. What does that mean? It means that it is estimated that projected, meaning in the future, it is expected that the model will answer correctly 99.99% of the time. Why is it so high, you might ask? One, the camera resolution here is pretty good. Like, it's a laptop camera, so I'm looking, at the camera itself. And I'm also doing a pretty simple one, like glasses on and off. It does get a little bit more complex. For example, if you're trying to detect defects in the manufacturing process, if you're trying to, assess whether the gate is closed or open, that obviously is going to take, more work to define what is open, what is closed. So I'm not surprised that the machine learning accuracy here is high. But if you want to take a look a little bit closer, here you see the best answer type. So this gives you the numbers of answers that were answered by cloud labelers versus no. And then here, first answer. So there's a difference between first answer and best answer. So here you will see first answer. So we had 2 instances, yes and no, in just 19 queries. So that is to say, out of 9, I took only 19 images, and the ML model was able to answer yes and no after only 19 snapshots. You can also click accuracy details, and you can see basically the confidence range for yes and for no. And so again, this is only 19. So you might be wondering like, wow, like the confidence range is huge. Well, out of 19 images, that is to be expected. And if you throw in more unusual cases, like if I were to take images of the, the glasses being held up in the air, what we call more edge cases, your confidence interval is going to be quite wide as well. It's going to need more guidance possibly to help instruct the ML model, like, hey, this is what wearing glasses is. This is what isn't wearing glasses. And I saw a question on, can you speak to data privacy with the images? Yes. So thank you, Drew. We are SOC 2 compliant. That is essentially one of the highest forms of data privacy. I'm happy to send you information on that as well. But that is to say, like your images and so like when you create the detector, those images are not being shared across other models, right? So like your glasses, your images, where you're training your model isn't being used to inform other customers' models. So you own your detector. No one has access to your images, outside of cloud labeling staff. Yeah, I'm happy to tell you a little bit more about SOC 2 compliancy, but it took us a lot of work to get that compliancy. It's not easy for a company to get to be SOC 2 compliant. So that was really exciting that we were able to achieve that. So kind of looking at my list. Yeah, so this is essentially pretty much an easy way for you to build your first computer vision model. So I would say then the next steps for people who are looking for, so the question then from here is, okay, like that's a cool toy. Like I can create, I can log into this dashboard and I can turn on my laptop camera and I can, the model can tell whether I'm wearing glasses or not. Well, okay, but how does that actually apply to the real world? First, I would invite you all to check out our YouTube channel because we have some really great videos that show the different applications of Groundlight. Let me share that. One second. Yeah, please feel free to look and subscribe. Yeah, so we have, for example, a lot of different like industrial use cases. We have PPE detection, automate detecting PPE. We have, yeah, this is the video on universal robots. But for people who are more advanced and are looking for a way to integrate into their applications and build custom applications, I will drop the link to this as well. But I recommend, I'll send this out as well, but we have a guide on using Groundlight's Python SDK. And guys, I've done this myself. I am not a programmer. I am not a software engineer. However, I was able to build my own custom application using Groundlight's Python SDK. It's very intuitive. But that said, if you are looking for help, assistance, we're happy to, walk you through it as well. But we have instructions essentially on how you would set up your detector, And essentially you're following the same format that we showed here in terms of like, defining your query and then capturing images. Here you'd have to make sure you have an external camera connected. So that's important to establish that external camera feed. So I would say highly recommend checking this out. I will put it in the link. 1 second. Okay, so just put that in the link there. And we also have a YouTube video that is linked to that page as well. So you can follow along with our software engineer, our robotics engineer, Tim.
Hello, everyone.
Does a really great job.
Industrial camera activate the environment.
Would, basically use Groundlight's Python SDK. Super great. So pausing there for any questions in terms of like using Groundlight's Python SDK. If anyone has questions on how to apply Groundlight to real business world applications. So just going to pause there. Okay, I don't think I see any more questions. So with that, I would say, let me finish with our last slide. I'll stop sharing. Thank you all for your patience. I am using 2 screens. Screenception. Okay, share screen. Yeah, so I will also copy this link address. We do welcome you to schedule a meeting with us if you want to basically brainstorm the different ways that you can apply computer vision, whether it's a hobby that you're looking to do, whether it's to build a custom application. We've had a lot of different ways to integrate Groundlight, whether it's through robotics, whether it's through retail or manufacturing processes. But maybe you have a completely different use case that you're looking to do, and we'd be happy to hear it. So. All right. Well, I think that's pretty much it. It's short and sweet. It's like I said, it's not too complicated. It's not rocket science. But I hope that you all enjoyed this demo. And yeah, I'd love to get in touch and continue the conversation for that. Thank you, Reed. And thank you everyone for joining. Thanks, Sydney. Thanks, Rishab.